So now that we know what the repeated games are in terms of their strategies and the other aspects, remain to speak about what the payoffs in the game are. Let's consider again the Prisoner's Dilemma game. Here it is. And we know what will happen at each stage of the game. So for example, suppose it so happens that the players cooperate both, and they both defect, and they both cooperate and both defect, and alternate this way forever. We know that they will get each will get the payoff of 3, then of 1, then of 3, then of 1, and so on and so forth. But the question is, how do you combine all those stage game payoffs into an overall payoff in this infinite game? We will see several answers. If the repetition is finite, that would be easy. You simply sum the payoffs, or perhaps you would take the average across this finite repetition, just a difference of a constant between the two. But when you repeat things infinitely, things are more complicated. You cannot simply sum them up. You could attempt to take the average, and this is called the limit average reward. So if you look at the stage game payoff, and you look at any stage in the game, call it X, and you look at the payoff to player 1, there will be some payoff, and it will be an expectation, of course, because in general there will be randomized strategies in that stage game payoff. And you can then sum over all stages up until T and take the average over all those T, and this is for a fixed T, and you will get some average payoff for those T iterations. You can now look at all T's going to infinity and look at how that average converges, and in the limit that will be a payoff. That's why it's called the limit average rewards. In general, a non-problematic issue. An alternative is to, as we'll see, is to say that somehow the present is more important than the future and discount the rewards you would get down the road. So $1 today is worth more than $1 tomorrow. And this brings us to the future discount reward formulation. And here the stage payoff is modulated by some discount factor beta. The beta will be between 0 and 1, to some power, the power of that stage. So the farther in the future you are, the lower the contribution of that stage game payoff. And again, you'll look at this, in this case, the sum over all the contributions from now to infinity, where the longer term ones contribute less and less to the overall payoff. Those are the two main ways we take all the stage games and combine them into an overall payoff. So a few comments on those. First of all, on the limit average reward, obviously now if we take our Prisoner's Dilemma and we alternate between stage games payoff of 3, 1, 3, 1, then the average will be 2. That's not problematic. The only subtlety that arises in the context of the limit average reward is that, in fact, that limit may not exist. In other words, those averages in some unusual situation, that series may not converge. And so you need to take the lim_inf to have this be well defined. Otherwise, the concept is straightforward. With respect to future discounted rewards, again, for the most part, non-problematic. Mathematically, again, if we have this infinite repeated payoff of 3, 1, 3, 1, and let's say the discount factor is 0.9, then the average reward will be 3 without a discount, then 1 with a discount of 0.9, then 3 again, but now with a discount of 0.81, and so on and so forth. You notice maybe a slightly unusual sort of use of language. When we say a high discount factor, it really means we're not discounting as much. A low discount factor means we're discounting the future substantially. This discount factor is something that is open to interpretation. It could, for example, really mean something about the future being less rewarding. For example, you could think of it as an interest rate where there's sort of an inverse correspondence to the interest rate that you get. Or you can view it very differently. You can say that the payoff you get will be that payoff, and it's as important to you if you were to get it in a week as it is now, but you're actually not completely sure that the game will continue. There's some probability, this discount factor, let's say 0.9, that at any point the game will end with that probability, and you'll never experience the rewards farther down the road. And in all cases, that leads to the same conclusion that the payoff today is more important than the payoff tomorrow, and the mathematics is, of course, the same in all cases. Now that we have this notion of a well-defined notion of a payoff for this infinitely repeated game, the solution concept is unchanged. We have the same notion of what a best response is. A best response is in terms of my payoff that's well defined right now, and a natural equilibrium is simply a strategy profile, one for each of the agents, such that everyone is playing the best response to the others. No change there at all. There is also a completely analogous definition of subgame perfect equilibrium. As an extensive form game, you might want to say something about the game should make sense not only now looking into the future, but also from a week from now, from then on. It should look sensible, and it's we do it in a very straightforward way. We can look at every history and look at the subgame starting from that point, as we did in game trees, in extensive form games. And so it is a proper subgame, the history starting at that node, and we'll simply use the notation saying, looking at the strategy of the agent starting at that point. It's a projection from the entire strategy to the part that starts at that point, and we'll simply require that that strategy be a best response to the strategies of all the other agents, again starting from that point. And now we have a strengthening of the notion of a natural equilibrium to be simply a natural equilibrium in each of the subgames starting at down the road. One last comment about the average versus the future discounted reward. As we saw, they're both well defined. They both give rise to well-defined notions of natural equilibrium and even subgame perfect natural equilibrium. It should be said, though, that it's more often that people refer to the future discounted reward because it is perhaps more intuitive and matches some of the applications people have in mind better.